Hi dear students, welcome to our channel Exam Side Mathematics by Bunny. In this video, we are discussing about differential equations. We are in exercise 9.4. In this video, we are discussing the method homogeneous differential equation. Here all the questions, it may take 5 to 6 videos every day maybe based on my possibilities. I will take it the classes half an hour every day, half an hour or 40 minutes based on that I will take. Here let us have a discussion the questions. Based on that I will take. Yeah. Show that given differential equation is homogeneous and solve each of them. First, the given differential equation, you have to prove it is a homogeneous differential equation. So, to prove homogeneous differential equation, here first the given differential equation write in the form of dy by dx equal to, so x square plus xy bring this side, dy by dx is equal to, dx we are bringing this side, and x square by x square plus y square by x square plus xy. This side it is the function in terms of x and y. So here this is equal to f of xy. You have to prove it f of xy is homogeneous function. See how to prove that is f of xy is x square plus y square by x square plus xy now. So I want to consider f of kx comma ky. So wherever x comma y is there, replace with kx comma ky. So it will become k square x square plus k square y square divided by k square x square plus k square xy. Am I right? So k square take common, x square plus xy y square by k square take common, x square plus xy. These two will be cancelled. It will be f of kx comma ky. If we express as here, both k values will be cancelled. We can write as 1 now. So 1 can be written as k power 0. The remaining is f of x comma y. If you are able to express in form of k power n into f of x comma y, then it is called homogeneous differential equation. Is here k square is there, so 2 degree. So here we can write it as k square fx square. Generally only either numerator or denominator we can consider the students. So we can write it as here k square is homogeneous function or homogeneous equation of degree 2. So we proved that it is a homogeneous function, is a homogeneous function of degree 2. We proved, half of the answer is over. Now they are asking to find solution of this differential equation. So come to here, dy by dx is equal to x square plus y square divided by x square plus xy. To evaluate the homogeneous differential equations, put y is equal to vx. Whenever dy by dx is there, dear students, x by dy is there, x equal to vy, that I am different. Differentiate with respect to x. Dy by dx equal to, here uv formula, u into v. So v into x derivative is 1 plus x into v derivative is dv by dx. So whenever y is there, replace with vx. So dy by dx value will become as what? V plus x dv by dx is equal to x square plus v square x square by x square plus x square v. Take common x square from denominator and the numerator, then it will becomes x square into 1 plus v square divided by x square into 1 plus v. So x square get cancelled. We bring the side, x dv by dx is equal to 1 plus v square divided by 1 plus v. V bring the side means minus v by 1. Take LCM on simplification. 1 plus v is the LCM. 1 plus v square into 1 minus v into 1 is minus v. Minus v into v is minus v square. So plus v square minus v square get cancelled. Now x into dv by dx is equal to 1 minus v by 1 plus v. Now we are going to separate the variables v and x respectively. Oh, till what step? More one step it is there. You are able to write here. So 1 plus v divided by 1 minus v into dv is equal to dx by x. Am I right? Taking integration on both sides, integral 1 plus v by 1 minus v into dv is equal to integral 1 by x into dx. After that, here 1 plus v by 1 minus v, we can express as, serious students, numerator in terms of denominator, we want to write it. Integral, can we write like this? 2 minus 1 minus v. So meaning is 1 plus v only. 2 minus 1 is 1, minus or minus v. So 1 plus v we are writing like this, divided by 1 minus v into dv. Integral 1 by x into dx. Now separating that, integral 2 divided by 1 minus v into dv minus integral 1 minus v by 1 minus v into dv equal to integral 1 by x into dx. Later 1 minus v get cancelled. 2 constant bring outside, integral 1 by 1 minus v into dv minus integral dv equal to integral 1 by x into dx. Okay? 2 into integral 1 by 1 minus v is log mod 1 minus v, and here v coefficient is minus 1, so it will be minus. Minus integral dv is v equal to integral 1 by x is log mod x. Plus log c we can write it, otherwise c we will write it here only. Here also we can write log c, here only better to write. So here minus I am taking common, 2 log 1 minus v minus plus v equal to log xc. This minus value bring here, and log 1 minus v whole square plus v equal to log xc whole power minus 1. This minus we are taking here. Otherwise, one more step to write it here. Both sides multiplying by minus, and we write it as m log a means log a. So log this v will be inside, log 1 minus v whole square plus log xc is equal to minus v. So wherever v is there, what we have to replace? Y. Y is equal to, since y is equal to vx, from that y by x is equal to v. Okay, dear students, you understand that? So log a plus log b, log 1 minus v whole square into xc is equal to minus v. So log of 1 minus y by x whole square into xc is equal to minus y by x It is base e only, dear students. If you remove this base, if you remove logarithm, we will get it as 1 minus y by x whole square into xc equal to e power minus y by x. Am I right? Next here, x minus y by whole square into xc equal to e power minus y by x. So we can write it as x minus y whole square by x square into xc equal to e power minus y by x. So one of the x cancel here, bring the sign. X minus y whole square into c equal to x into e power minus y by x. So x minus y whole square equal to x by c into e power minus 1 by x. X minus y whole square equal to x into capital C e power minus y by x. Since we are taking 1 by c as capital C. This is the required solution to the given differential equation, dear students. I hope you understand. We'll move on to another set of questions. Yeah, we'll move to the next question. So y dash means dy by dx is equal to x plus y by x, that is equal to x by x plus y by x. So dy by dx is equal to 1 plus y by x. So you take this is f of x comma y. This is equal to f of x comma y. F of kx comma ky equal to 1 plus ky by kx. Again we are getting f of 1 by x only, no? Whenever you are expressing f of kx comma ky equal to f of x comma y form, then it is called homogeneous equation. Homogeneous equation. Here what is the degree means? Only 1 degree. Okay, dear students. Homogeneous. In every term the power of x is 1 only, so it will be 1 degree. It is a homogeneous equation of degree 1. Of degree 1. Irrespective of variables x and y, each and every term containing only 1. So it is already we proved no. So therefore the given differential equation is dy by dx equal to 1 plus y by x. So to solve this one, put y equal to vx, differentiate with respect to x, dy by dx equal to uv formula, v into x derivative is 1 plus x into dv by dx. So dy by dx equal to v plus x dv by dx. So in place of dy by dx, replace with v plus x dv by dx equal to 1 plus v. Both sides v get cancelled. X into dv by dx is equal to 1. Separate the variables. dv equal to dx by x. Taking integration on both sides. Integral dv equal to integral 1 by x into dx. Integral dv is equal to integral 1 by x into dx. Integral dv is v. Integral 1 by x is log mod x plus log c. So v means what? Y by x equal to log a plus log b is log ab. So log x, c to the base e. So e power y by x is equal to xc. This is our required solution to the given differential equation. I hope you understand. We'll move on to another set of questions. So from the given differential equation, x minus y into dy equal to x plus y into dx. Dx bring this side. Dy by dx equal to x plus y divided by x minus y. Okay. After that, this is f of x comma y we are taking. First, you decide whether it is homogeneous of degree n or not. N means here, we will check it. F of kx comma ky. Every term is having x power is 1, y power is 1, here also 1, here also 1. So, 1 degree. So, kx plus ky by kx minus ky equal to k times of x plus y by k times of x minus y. This is f of x comma y. So whenever you are expressing f of kx comma ky equal to f of x comma y, then it is called homogeneous homogeneous equation. It is homogeneous equation of order 1. Order 1 or degree 1? Better to write degree of degree 1. We decided that they are asking to prove that it is homogeneous. Yes, it is homogeneous. Next, dy by dx is equal to x plus y divided by x minus y. To solve these equations, we need to consider put y is equal to dx. Differentiate with respect to x. Dy by dx equal to v plus x dv by dx. So now substitute in this v plus x dv by dx is equal to x plus vx by x minus dx. X take common and cancel. V plus x dv by dx is equal to 1 plus v by 1 minus v. X get cancel, v bring this side. So x into dv by dx equal to 1 plus v by 1 minus v minus v by 1. Take LCM and simplify. X into dv by dx 1 minus v 1 plus v minus v plus v square. Okay, so these two will be cancelled. Now we are going to separate the variables. Are you able to see? Yeah, one more step we can. One more step we'll write it here. So 1 minus v by 1 plus v square into dv is equal to dx by x. Whenever variables are separated, we can take the integration on both sides. Integral 1 minus v by 1 plus v square into dv is equal to integral 1 by x into dx. Now we can split into two integrals. Integral 1 by 1 plus v square into dv minus, here multiplying and dividing by 2 to get f dash of x by f of x into dx formula. Integral 1 by x into dx. I hope you understand here. Here we are going to apply integral f dash of v by f of v into dv equal to log mod f of v. It is understood now. We did number of questions in the previous exercises of integration. So integral 1 by 1 plus x square. Integral 1 by 1 plus x square dx equal to tan inverse x. So even this is also formula. Tan inverse of v minus f dash of x by f of x means half into log mod 1 plus v square is equal to integral log 1 by x is log mod x plus log c. So this value bring the sign. Tan inverse of v equal to 1 by 2 log 1 plus v square plus log x plus log c. So tan inverse of wherever v is there, replace with y by x is equal to half into log mod 1 plus y square by x square plus log xc. Log a plus log b is log a. Next term, tan inverse of y by x equal to half log x square plus y square divided by x square plus log xc. We can leave it like this. Why? Because answer in terms of half log only it is there. This is the required solution to the given differential equation, dear students. Yeah, we go to another question. So first what we have to do, we have to prove that it is homogeneous differential equation, homogeneous equation. So x square minus y square into dx is equal to minus 2xy into dy. So dx bring the side, and if you remove minus, these two will be interchanged. So y square minus x square by 2xy is equal to dy by dx, which is equal to f of x comma y in terms of x and y is there. So in each and every term degree is 2, no, it is a second degree homogeneous equation. Here x power 1, y power 1, irrespective of variables, the term is having the same degree. So f of kx comma ky is equal to k square y square minus k square x square by 2 times of kx into ky. So k square take common, y square minus x square by k, here also k square into 2xy. Okay, dear students. So this is equal to f of x comma y only. So it is the homogeneous. It is homogeneous equation of degree 2. We prove that it is homogeneous. Next, what we have to do? dy by dx equal to y square minus x square by 2xy. Put y is equal to vx. Differentiate. This is the common rule to solve the differential equation, homogeneous differential equation. Put y is equal to vx. So differentiate with respect to x, dy by dx equal to v plus x dv by dx. So wherever y is there, replace with vx, and wherever dy by dx is there, replace with this value. So v plus x dv by dx is equal to y square means v square x square minus x square by 2x into vx. So v plus x dv by dx is equal to x square take common, v square minus 1 divided by x square into 2v. X square get cancelled. We bring this side, x into dv by dx is equal to v square minus 1 by 2v minus v by 1. So x into dv by dx is equal to 2v is the LCM, v square minus 1 minus 2v square. Now separate the variables, dear students. X dv by dx is equal to minus 1 minus v square. Why? Because minus 2v square plus v square is minus v square by 2v. Now variables separable. Before only minus I am taking common, 1 plus v square divided by 2v. Minus I am keeping here only. So 2v divided by 1 plus v square into dv is equal to minus 1 by x into dx. Variables are separated. Whenever variables are separated, taking integration on both sides. 2v by 1 plus v square into dv equal to minus integral 1 by x into dx. Again this one, integral f dash of v by f of v into dv is equal to log mod f of v. Even it is there in this form, dear students. 1 plus v square derivative is 2v only. So what comes here? Log mod 1 plus v square is equal to minus log mod x plus log c. Now minus log x bring this side, log 1 plus v square means y square by x square plus log x is equal to log c. So log of x square plus y square divided by x square plus log x is equal to log c. Log a plus log b, log ab. So log x square plus y square divided by x square into x equal to log c. Comparing log functions, x square plus y square by x equal to c. So x square plus y square equal to cx, which is the required solution to the given differential equation, dear students. I hope you understand. We'll move on to another set of questions. fractions. First, x square bring this side, dy by dx equal to x square by x square minus 2y square by x square plus xy by x square. dy by dx equal to 1 minus 2 into y by x whole square plus y by x. This is equal to f of x comma y. Even here also y power 1. Here in this term degree is 2. In this term degree is 1. In this term degree is 0. So it is a homogeneous. Every term see here 2, here 2, here 2, here x power 1, y power 1. It is a homogeneous. So given f of x comma y is homogeneous of degree 2. Next, dy by dx. This one is there, no? So put y is equal to dx. Differentiate with respect to x. dy by dx equal to uv formula. v into x derivative is 1 plus x into v derivative is dv by dx. So in place of y replace with this value, this equation will become v plus x dv by dx is equal to 1 minus 2v square plus v. Both sides v get cancelled. Now 1 minus 2v square bring this side. So dx into dv by dx equal to 1 minus 2v square. So dv divided by 1 minus 2v square equal to 1 by x into dx. Dx will bring this side. Taking integration on both sides. Integral dv by 1 minus 2v square equal to integral 1 by x into dx. Here 2 take common. 1 by 2 we are taking common. So dv by 1 by 2 minus v square equal to integral 1 by x into dx. So this one we can write it as 1 by 2 integral 1 by 2 can be written as 1 by root 2 whole square minus v square into dv is equal to integral 1 by x into dx. Here we are going to apply this formula. Integral 1 by a square minus x square dx equal to 1 by 2a into log mod a minus x by a plus x. I hope you understand. You remember the formula. So 1 by 2 into 1 by 2a. 2a means what? 2 into a value is 1 by root 2. Log mod a minus x by a plus x. So 1 by root 2 minus v by 1 by root 2 plus v is equal to log mod x plus log c. Here one of the root 2 get cancelled. 1 by 2 root 2 log mod 1 minus root 2v divided by, here also 1 plus root 2v will come, is equal to log xc. Okay, dear students? So 1 by 2 root 2 log mod 1 minus root 2 into y by x by 1 plus root 2 into y by x equal to log xc. take LCM and simplify 1 by 2 root 2 log mod x minus root 2y by x plus root 2y is equal to log mod xc, which is the required solution to the given differential equation, dear students. I hope you understand. I'm going to end the session for this today, and for the rest of the questions, maximum 5 to 6 questions in the session I'm going to discuss in this exercise. After that, we'll go to another concept. Thank you for watching, dear students. Exam side mathematics by Pani. Please do subscribe those who are watching first time. Please, my intention is most of the students are having in remote areas the internet availability is there, but not available of tuitions and academies. At least they will utilize our services. That is my intention to make these videos. Please do forward to the required students, the needy students. Thank you all for your support. Jai Hind. Exam site mathematics by Pani. ఇప్పుడు ఇక్కడ ఏం చేస్తారా ప్రైవేట్ దాంట్లో పడిపోతుంది.